Here's a question that involves relative speeds. So it's a bit tricky to wrap your head around, but it definitely, once you get the hang of it, you definitely get the idea of how these questions work. So Mr. Chung is driving his motorboat across the lake, and this lake is 2,400 meters long, and he has some wind. Okay, with the wind, he's able to cross the lake in 40 minutes. And when he navigates back across the lake, with the wind, it takes him an hour. So he has wind pushing against him. Now, if the wind speed is constant, in other words, we're assuming that the wind does not change, we want to find the speed of the wind and the speed of the boat in still air. In other words, we want to find how fast the boat would go if there were no wind at all. So that right there allows us to define our variables. I mean, it's very simple to identify what we want to solve. So we're going to say let x represent boat speed, and we have to say boat speed in still air. In still air. And the y value represents the wind speed. Y represents wind speed. Okay. Now, before we begin setting up our equations, we need to recall some facts, okay? I know that speed is equal to distance over time. If I rearrange this equation and solve for distance, and I put the time there, I get distance is equal to speed times time. Okay, so we're going to use that equation for distance when putting together our equations. In addition, I want to express everything, all my final answers, in kilometers per hour, because those are familiar units to us. I mean, if you drive a car or have been in a car, you know that it goes in kilometers per hour. So that means right away we have to convert this meters business into kilometers. So 2,400 meters is equivalent to 2.4 kilometers. Similarly, 40 minutes here in the time, and 1 hour, if I were to convert that into hours, well, the hours is an hour, so that we can leave. But 40 minutes, what's that in hours? Well, 40 minutes is the same as 40 over 60, because there's 60 minutes in an hour. And I'm just going to reduce that to 2/3, which is 0.66 repeating, but I'll leave it as a fraction just to be safe. So let's start with our equations. I know that Mr. Chung, when he goes with the wind, so let's suppose he starts over here and he wants to go to this side of the lake, okay? He has the wind at his back. So if he is going at the speed of, what did we say Mr. Chung was? If his boat is x, okay, so his speed is x, and then we add the velocity of the wind, which is y, that will be the total velocity of Mr. Chung crossing the lake. Okay, so using that velocity, x plus y, I'm going to multiply that by the time it takes him in hours. And I know that is 2 over 3. And that is equal to 2.4. Again, I'm using this equation here for distance in terms of speed and time. Okay, so speed here is x plus y. The time is 2/3, which is 2/3 of an hour. So let's delete all that. So for the second equation, he's going back across the lake. So Mr. Chung's boat speed is x, but this time, let's go to our diagram. When he goes back across, so from here to here, we are subtracting the wind from his speed because the wind is pushing against him. So what I have here then for speed is x minus y, and that's times 1 because it takes him an hour, and that is also 2.4 because he's traveling the exact same distance. So that 1 I don't have to write in. I don't need these brackets. I'm just going to write x minus y is equal to 2.4. So now I'm in a position to rearrange my equations so that, first of all, I want to get rid of this fraction here, and I can start solving. So I'm going to begin by eliminating this fraction. I'll rewrite it as 2 times x plus y over 3, and that equals 2.4. I'm going to bring this 3 up at the top here. So I have 2x plus y is equal to 7.2. And to simplify it even further, I'm going to divide both sides by 2. This cancels this, and 2 goes into 7.2, and I'm left with 3.6. So this equation, once it's simplified without any fraction, becomes x plus y is equal to 3.6. So here's equation number 1 modified. Here's equation number 2. And I think I can solve using elimination or substitution. We can pick. I think I'll go with elimination. So let me take a copy of this equation, put it here. And I'm going to take a copy of this equation, carefully cut it out, and put it here. And I want to eliminate, I think in this case I'll eliminate the y value because I have a negative and a positive y. I'm going to add the equations together. So x and x gives me 2x, the y's vanish to 0. I get 2.4 and 3.6. If I add it together, it gives me a total of 6, which means that x is equal to, well, I'll put the in-between step. I have 2x is equal to 6, which means that x is equal to 3, and that is my boat speed. Finishing off, to get my speed of the still air, I'm going to plug this 3 into one of my original equations. Let's say I'll plug this 3 into this equation over here, and that gives me 3 minus y is equal to 2.4. Bring the 3 over, I get negative y is equal to negative 0.6. Y is equal to 0.6. So there you have your expression for the speed of the wind. It is 0.6 kilometers per hour. And the speed of the boat is, what do we say, 3 kilometers per hour. That's kilometers per hour. And that is a